Hi, and welcome to this SQL Bits session on ethics and bias. My name is Rob Lester. I'm a cloud solutions architect at Microsoft. I work in OCP, one commercial partner, and I specialize in databases and machine learning. So, within this session, we are going to be talking about social and ethical impacts and the latest advances in data science, how to understand where bias lies, how to collect data correctly, and we'll look at toolings to use to help you understand your data sets. Now, in this talk, this is really kind of an ideas talk, talking about the concepts. We're not going to go into any too much technical depth. We will mention in passing the tooling, but we're not going to go into depth about how that tooling works, etc. Keep this high level because it really is to understand what you need to be doing in terms of data science. What are the problems? How can you create data science in a morally and ethically way. So we'll start off, we'll look at the social cultural impact of AI. This is the Standard & Poor Index. You may have seen this before. It's how long organizations basically stay within on this index. So as we can see, we're in a digital revolution. There's lots of shifting things around. Organizations are disappearing. Organizations that aren't taking on the new way of doing things. So, for example, HMV has lost out really to organizations such as Spotify. We see Blockbuster disappearing because organizations such as Netflix, etc., have now cornered the market through digital revolution. So lots of organizations, bricks and mortar organizations, are kind of going to the wall. And lots of organizations are disappearing that aren't embracing AI. So AI is giving lots of organizations competitive advantage. It's speeding up the processes. It's giving them better security. It's giving them better understanding and making them more flexible and easier to adapt. Things such as customer churn, being able to hold on to your customers, you can do with AI. If a customer is much more valuable to you as a customer that stays with you as opposed to trying to fight to get a new customer. It's 5 times, I think, yeah, about 5 times more expensive to bring on a new customer than it is to maintain an existing one. So using AI to basically give yourself competitive advantages to help you stay as a top company. And not disappear as other companies have that haven't been flexible in changing their business model into the new way, the new digital revolution. So if we look at the UK, this was a report that we released last year. I think it was last year, might have been earlier this year. How organisations are progressing in their AI journey. So we can see that in the UK, 56% are doing something, 34% aren't doing anything. We only have in total 8% organisations that are doing advanced projects. Most UK organisations are experimenting at the moment. That will change because the benefit from AI, like I said, the competitive advantage is becoming higher on CEOs' list of priorities. So more and more organizations will be taking up AI. Hopefully your organization is using AI or thinking about how you can use it to give yourself a better advantage in the marketplace. I presume you are by the fact you're attending this talk. So this like I said, this report that's released, the link is in the bottom right. We can see that the UK we're doing AI organizations are outperforming organizations that aren't using AI. However, as a country, we are falling slightly behind some of the other nations, such as US and China, in terms of the amount of investment we're putting into AI and driving AI forward. Now, the kind of key areas that we see people using AI, smart digital assistants, so that's your bots. I'm sure everyone talks to a bot some way, even if it's just talking to like a device such as Alexa, Google Home, something like that. There's a Gartner statistic by 2020, you have more conversations with bots than you will with your spouse. We see organizations doing voice recognition. We can see organizations using machine learning to like things like customer churn. And there's also quite a surgence we see in terms of a vision and being able to understand things in the real world. Um, and using this thing, like I say, competitive advantage, speeding up, automatic process automation, having extra levels of security. So using someone's face to identify them, using someone's voice to identify them. You may have come across that if you do telephone banking. So all of this, all the stuff that's been happening in terms of the digital revolution has caused some problems in terms of hypercapitalism. So what does this mean, hypercapitalism? It's effectively a state where the demand on new skills is outweighing the ability for people to be able to get those new skills. So there's you're probably aware that we have a shortfall in terms of data scientists. It's a very popular job, data scientist. Now we're doing a lot in terms of democratizing AI and making it easier for people to become data scientists, but there's still a shortfall in terms of that job is a very much in-demand job because there's problems where all these new roles are coming available and there's not enough people to fulfill those roles. So if we look at the chart on the right, we'll see that roles that are starting to become redundant are roles that we can automate. So things such as data entry clerks, accountancy, things where there's very strict rules that you could train a machine learning model to do. Things like delivery drivers, so driving a car. This is obviously quite a big problem because one of the if you have been unfortunate to not have a full education, the highest paid jobs out there, it's certainly a statistic from the US, the highest paid jobs out there are driving jobs, so delivery drivers, taxi drivers, which you can do without having going on into any kind of further education. With the problems that these jobs are now potentially at risk if once driverless cars become more prevalent, then it causes a bit of a social unrest in terms of people's jobs are being eroded, and people need to retrain, reskill into new jobs, and the new jobs are new jobs that are potentially you need some other style backgrounds to perform. So something like a robotics engineer is going to take a taxi driver a bit of training to move from being a taxi driver to a robotics engineer. So potential for social unrest and social upheaval brought on by hypercapitalism, and just the destruction of jobs and creation of new jobs. I mean, it's not all doom and gloom. There's Gartner statistic, 1.8 jobs are expected to be lost to AI by 2020. Well, we're here now, and 2.3 million jobs will be created. So there are new jobs, but like I said, there are generally more complicated jobs to train into. Now, this is a great quote from Director of London School of Economics. In the past, jobs were about muscles. Now they're about brains, but in the future they'll be about the heart. So jobs that will never become eroded are jobs around things like doctors, nurses, psychologists, psychiatrists, and anything that gives care and anything that needs a kind of human interaction. There's studies happen before where people have gone to a GP, and if the GP was a robot, they would be less likely to take the advice of the robot, even if the robot was giving more accurate advice. So there are scenarios certainly where jobs will never disappear because people respect the human interaction and don't want to just be talking to an AI. Okay, so impact on jobs. So these are a few crazy examples from around the world. More kind of fun, really. So there's on the left we have a fashion show in Saudi Arabia where they're using drones to move the clothes down the catwalk. Obviously loses quite a lot in using the drones. We see San Jose Airport have got these robots that go around that you can ask for to help you find different things as well. So there's a few kind of extreme examples, but coming back to more realistic things that will more likely to take off, or autonomous vehicles, a great example. Autonomous vehicles, people don't often understand the impact that these would have. So we're talking about new things that are happening in AI and stuff that's going to cause disruption. Autonomous vehicles, obviously, there's going to be uh, uh, this is going to be cheaper because you don't have to pay people if you have taxis that are autonomous. Um, you then have problems of if there's an accident, who's responsible for the accident? Is it the person that was sitting in an self-driving car? Is it the person that developed the code? Can you get insurance for self-driving cars? Who has the liability? We see that obviously the destruction of jobs. But other things that are kind of side effects of these are that once you have self-driving cars, you don't necessarily have to have car parks. So if we look at this is a map of Manchester, and if we look on this map of Manchester, excuse me, in all the grey areas are parking lots. If you have self-driving cars, if no one needs to own a car, no one needs to have can just use their phone and go from A to B using a self-driving car. There's no need to have car parking lots. You don't need to take up all that space in a city. So those then that you have difference in kind of real estate becoming available because people don't need to go in, and then you have to think about impact on things such as hotels and that kind of stuff. If you have a self-driving car that's got the ability to sleep in, maybe you don't need to. If you need to be in another part of the country, you don't necessarily need to go to a hotel the night before, stay there, and then do your business. You could go in your car and sleep in your car if you trust the car, that is. Um, okay, so we've talked about that. Now, in terms of where we are with AI, we're still not quite there. It's still quite easy to trick AI into seeing things. AI doesn't work the same as a human brain, and we're going to talk about some of those problems as well today. So we need better explainability, better testing in our models. So the sign on the left, we would see this as a stop sign, but machine learning algorithm might see that as a limit to 45 miles an hour, just because of the what we've done in terms of the pixelation around it. It's looking for certain features of those stop signs, of the signs, so it would misclassify that stop sign as a 45 mile an hour. So that's the way we need to think about how machine learning works, and we think about what with full machine learning models as opposed to what would fool a human. We've talked about that. Okay, so where are we going in terms of AI? So we sit in the narrow artificial narrow intelligence aspect of AI. So machines can only do certain things. They have a narrow understanding of the world. They only have the understanding of the world that we give them. They have three different problems: frame reference, and symbol grounding, and feature engineering. I'll explain them in a minute. The next stage, which we may get to, who knows, in several decades, might be artificial general intelligence, where machines can behave and think like humans. They can understand outside of their domain. They can they can act more human-like in terms of being able to go out and find data and make decisions themselves. And then we get into the far future where we talk about artificial superintelligence, where we end up in a world where the artificial intelligence is smarter than people. So by that time, we just have to hope that we created benevolent artificial intelligence and we're not in a Skynet Terminator style dystopia. Okay, so let's talk about where we are at the moment, frame reference problem. So AI has no common sense at all. It only understands things in the world that it's given. Um, so if you were to say to an AI, please, in this example below, we say to the AI, turn off the light switch. It could turn off the light switch by hitting it with a baseball bat. It could turn off the light switch by the switch. It could turn off the light switch by cutting the power to the house. It wouldn't have no insight into, hold on, if I cut the power, I may not be able to charge myself. If I smash it, there may be glass on the floor. It's kind of very simplistic way it kind of sees the world. It can only see the world in the elements that we give it. So that's a frame reference. It only understands the world in the frame of reference that it has been given, because it doesn't really have the skills to go and understand outside of that. For example, here we have a picture of a cat, and then we have a picture of a dog. And then this picture, as humans, we know that this isn't a cat or a dog. We know it's probably something else. But the problem with artificial intelligence is it would, if it only understands what cats and dogs are, it would have to classify that as a cat or a dog. So it might say, well, I'm 51% sure that's a cat, so I'm going to say cat. It doesn't have the ability to look outside of the frame of reference it's been given, like we do. So that's a simple grounding problem. Machines cannot construct knowledge. They only understand knowledge as marks. So we can create. In fact, we have created the ability to go from English to Chinese. We have Microsoft. We developed a deep neural network that will do that better. Will do that better than a human can do it. So we can do the translation better than a human. However, the machine learning algorithm doesn't understand what English is. It doesn't understand what Chinese is. It can't speak Chinese. It can't speak English. It just knows the rules to move from the English to Chinese. And then the kind of third problem is how the world is understood. So for this example, we talk about chair. We can see that's a chair. We know where the chair ends and the floor begins. We know where the chair has a cushion on it, and a cushion is not a chair. We know how to identify and see what these things are. A machine learning algorithm has a feature engineering problem where it can only understand by the features it's been told to understand it. So if we know that we're not going to, there's no point in tasting that chair, because that's not going to give us any knowledge. There's no point in squeezing the chair to see how soft it is, because that's not, we've already understood the chair without those elements. But machine learning algorithm needs to be told how to understand a chair. So it doesn't understand to get the right features to understand something. So these are the kind of problems we have. Now, we're doing a lot in terms of driving innovation at Microsoft. So as I said before, we've reached human parity in English Chinese translations. We've also reached human parity in terms of understanding voice, understanding images. So we can sit someone in a room and give them 10,000 images and use one of our algorithms to classify those images, and the algorithm will do better than the human. Same with speech. And we can see things. You can see that kind of stuff happening. For example, at McDonald's, if McDonald's will be using a cognitive services algorithm, and when you talk to it, it uses one of our algorithms to understand what you're saying, which will be better than the person serving at McDonald's. And it's been trained to understand that there's traffic noise. It's been trained to understand that there is potentially engine sounds, background noise, horns, people talking about other things. So it can filter that out, just like a human would filter out, but it does a better job of filtering it out, and best does a better job of understanding the domain of what it's been told, which is words, and also particular words such as Big Mac and McNuggets, etc. So we're kind of on the cusp of a few different things happening in the world, new ideas and new ways of using machine learning. This is quite an interesting one that has happened recently, using machine learning to stimulate parts of the brain, which will let you learn things quicker. So the problems that arise from these kind of technologies are that you start to have to think about who has the power of machine learning and where that's going to be placed. So, for example, if this advantage of being able to learn things quicker through stimulation of particular parts of the brain, obviously you can't upload data into the brain as yet, but we can make people learn quicker. Is that going to be just an elite that gets that advantage? Is it just going to be an elite that's going to be able to load things quicker and better? So are we creating a superclass? And then again, reference back to all those dystopias, like 1984 and all the science fiction kind of stuff around that. This is quite an interesting case that happened recently where we're talking about the ability for machine learning to be able to being better at people at understanding voice, but we can also now make machine learning models that can speak. And those machine learning models can talk in a way and be trained in a way that they can fake someone's voice. So we had a case where there was a German company with UK offices. The CEO was German, and someone recorded his voice because CEO's probably got lots of him doing talks out there. So they took his voice, they ran it through a deep neural network, and they were able to emulate his voice patterns and how he speaks. And they were able to call out the UK division of that German company and ask them to transfer in the CEO's voice, ask them to transfer $243 into a different account. Because they heard the CEO talking, they did it, and excuse me, they got away with $250,000 in doing that. So there's with machine learning, there's lots of metrics now. Obviously, this is a non-ethical thing to do. There's lots of attack metrics now that we need to take into consideration, and we need to think about how machine learning is being used um, and what's a good way and what's a not good way of using machine learning. This is very clearly a bad way. We're going to talk about some other ways and some things where it's not quite as clear cut, because once we start talking about ethics and morality, it's things it's there were opposing views, yeah, etc. So let's go into ethics. So it's a quote from Brad and Harry. Ultimately, the question is not what computers can do, is what computers should do. So we saw that thing with the CEO, German CEO, faking his voice. Obviously, that's not something we should do. But we also need to start thinking about other things and the impact of how we're using AI and the models that we're creating, and the impact that we're going to have on other people, be it known or unknown. So just to put all of this in a bit of perspective, when we talk about ethics, you may have seen this before, it's the tram problem. When we talk about ethics, we need to think there's really kind of two schools of ethics. There's the duty and moral obligation. So if you ever read any Kant, then that's all about you should never kill someone regardless of the outcome. And then we have ends and outcomes. So kind of utilitarianism, where we think about the greater good. So for this tram problem, if a tram's running down the track, do you switch the tram to go and kill the one person, or do you leave the tram running on the track to kill the 5 people? So if you had decided that it's morally incorrect to ever kill anyone, you wouldn't swap the tram over. So it's bad to kill that one person. But if you think that the greater good, i.e., less people get killed, then you would swap it over and let that one person die and let the 5 people live. Most people generally don't. Most people generally will swap it so the one person dies and the 5 people live in this problem. There's another version of this problem where it's pushing a man off a bridge onto the track, and then it kind of reverses around, because once people start thinking about the actual, rather than just putting a switch, actually pushing someone and pushing them onto tracks to stop those people dying, then it becomes a bit more real. But anyway, so when we talk about ethics and bias and etc., there's no clean cut way of doing things. There's generally what's acceptable, generally what is what's good, as we can see from our kind of cultural identity, etc. But there wouldn't be a school of philosophy and of ethics if it was just all black and white. Okay, so how do we identify sensitive uses for AI? So if we think about ways that we think about the kind of 3 key areas that we want to think about in terms of sensitivity. So AI systems that make automated decisions, recommendations that impact on services a person receives. So that's a potential problem. Because, for example, loans. If you have a system that is allocating loans and it's based on the color of someone's skin, their gender, that's going to be a non-ethical system. We need to think about systems that cause harm, so physical, emotional, psychological harms. So we talk about minorities, ignoring minorities. So a very classic one is face identification. A lot of face identification software doesn't do as well in identifying black people as it does white people. So the training data that's being used has not been it's not been representational and has marginalized people. So when we're creating systems, we need to think about those aspects. And we need to think about if our systems that we're creating, our machine learning models, are going to infringe on human rights. So if we're going to, classic one would be the right to privacy. Are we creating something that is going to take away someone's right to not be identified? And I'll give you some examples of these, but really want putting these up for you to kind of think about the examples that we're going through in respect to and think about these three cases in respect to the examples that we go through. If we talk about legal obligations of and ethical obligations in terms of legality, etc. In the UK, biometrics is covered in UK law, DNA, but around DNA and fingerprints. There isn't really any, and this is the problem with any new field, is that the systems are always the legal system always takes longer to catch up to what should be happening. Technology always moves a lot faster, so we end up with situations that where at the moment faces, videos, emotions, etc., can all be captured, people's heartbeats, where people are looking, etc. So that we need to think about it's what's ethically acceptable, because we don't know at the moment, we have no real legal framework to define that for us. So things such as, is it acceptable to record people on street cameras so we can identify who a suspect is? Is it acceptable to keep to record children so we can identify if they've been abducted children, etc.? Is it acceptable to when people walk into a shopping mall to identify who they are and have a history of what they've bought and all their interactions? So these are the kind of problems that we need to think and we need to address. Are we doing any harm? Are we infringing on people's privacy in order to increase the potential of selling to that individual? Are we infringing on people's privacy in order to try and catch someone that shouldn't be on the streets? Here's a good example of along these lines. So this is New York Police Department. Was found that there was someone that was stealing uh, alcohol from a store. All the reports said that he looked a bit like Woody Harrelson. So they trained a model using Woody Harrelson's face, and they were able to use cameras to capture this this alcohol thief using Woody Harrelson's likeness. Now, did Woody Harrelson consent to that? No, he didn't consent to that. So, is it acceptable to infringe on his privacy to use his face to capture someone that just coincidentally looks like him? So we think about personal boundaries. This is quite a classic example from 2 years ago, where a deep neural network was created that was able to identify people's sexual orientation. So in this case, it felt it was 91% accurate in identifying if a man is straight or gay, and 85% accurate in determining if a female is straight or gay. Now, obviously, if you use that and walk into a room, lots of people wouldn't want to have a machine learning algorithm identifying or attempting to identify on their sexual preference. There's other examples more recently where we've seen mobile phone apps that will use deep neural networks and give you an image of them without their clothes on. Again, infringing on kind of personal boundaries, etc. Here's another classic example at Chinese school, Big Brother. Well, in fact, this is where they have in the classrooms, they have a camera, and that camera will identify negative emotions. If someone shows negative emotions when they're at the school, they'll be asked to stay behind as to why they weren't learning. So end up with lots of people with poker faces really, not wanting to show any kind of emotions in that school. Is that acceptable? And just moving on from that, China, this example is showing China's has a 50 megapixel camera they've just developed that can identify every face in a crowd. So obviously law enforcement, that's pretty good, but is that infringing on everyone else's rights? And here's an example where this is from she's a pop singer, and is a pop singer in, I think it's Japan, and she takes very high res photographs of herself. But she had a stalker. That stalker was able to zoom in on her eyes, and from her eyes identify where she lived by the reflection of things like bus stops and that kind of stuff. So with the digital revolution, we're in a world where things that just the fact that our fidelity, our quality is greater, means that there's going to be potential for people to start mining more and more information and using data science to be able to gain more and more information about you, that is not necessarily information that you wanted to offer out. So she only wanted to offer out the fact of her pose and a picture of herself, not the location that she was taking that picture from. Now, there's been a lot of talk about using robots and using automated weaponry, because for start, automated weaponry, if you're using, it's not a human. Once you automated it, it's not a human making the decision on who to kill and who not to kill anymore. So that's obviously a bit concerning, and also it creates the potential to have different political structures, but it's different people with power. So, for example, normally in a country has an army, and that country is controlled by the political establishment. If you can buy an army of robots that can kill, then it's a huge power shift from a elected political party to someone with a lot of money. So that's quite worrying. Um, and oh, sorry. Then this this image here is from Boston Dynamics, um, and we kind of getting to the point where we have robots now that can move around. So with robots and the ability to, we're starting to get AI, and we were talking about before about moving on into more intelligent AI. We see here pictures of these robots being tested, but probably a lot of you, this will produce an emotional response. The question is, should it be producing an emotional response? Should we be concerned because they don't have any, there's no harm being done to them, but in our minds, it does look like it's not a very fair way to treat something. As things get more intelligent, as we start moving into the next few decades, this might be something that we need to start considering in more depth. Okay, so let's talk about bias. So bias, we talked about killer robots and this kind of things, but the main problem we see at the moment in terms of data science is bias. She quotes here, forget killer robots, bias is the real AI danger. And bias is kind of inherent in everything that you do as a data scientist, and it's something that you should be aware of. If you're not thinking about bias and ethics when you're creating machine learning, you're probably creating some unethical models. So where does bias come from? So bias comes from your data. So you train a model with the data. If your data has got faults in it, then you're pushing the bias that's in the data into the model. So it might be intentional bias that you're pushing in. It might be subconscious bias. It might be your problems with collecting data. So we'll talk about some of these problems. It's very key to understand how you might have bias problems when you're creating models. So unrepresentative models of the world. So if we have missing data or wrong training data, then that could be a problem. For example, if I was for example, if I was trying to get some information on what makes a good film, if I had gone to collect all that data and at the cinema I asked a group of people that have gone to see the latest blockbuster action film. What makes a good film? That's going to be non-representative. It's likely to be a certain age group. It's likely to be specific, more inclined to specific genders, and I'm likely to get things that will not talk about kind of key elements of films that different people want to would be interested in. So I'm just collecting the right data, making sure that you're collecting the data in a way that means that it's correctly representational of the world. And then accurate models of the world. So social biases, kind of embedding training. We'll talk about that in a minute. So bias in data collected. This is some great uh, uh, surveys from the Trump administration that show it's kind of well, in fact, this one was Fox News that show how to not collect data correctly. So this one says, how would you grade President Trump's leadership in the fight against the Wuhan virus? Superb, great, very good. There is no way of saying actually poor, not very good, okay. It's the data collection is biased, so they will only get data back that says that Trump did a great job. No other data they will get, either superb, great, or very good. It's a very obvious example. Some other ones that we can see in terms of data collection if you're surveying. I like this one at the bottom. How do you limit how much pizza you eat? Because sorry, do you limit how much pizza you eat because it is unhealthy? Most people are going to say, yeah, I do, because pizza is unhealthy, so I'm not going to, I'm not going to just eat and eat and eat it. So you're always going to get a yes answer for that, because in the question you've put bias, so you're telling them that pizza is unhealthy, and do you limit that because of that? Um, so um, so some other ones from the Trump campaign, because it's a great source of biased questionnaires. Um, so I'll let you read these in interest of time. You can pause the video, but they're all biased. This is quite a good one as well. So this is Trump's first year, inaugural year approval poll. How would you rate President Trump? So you can have great, good, okay, other, and how would you rate President Obama? And Obama has the addition of poor. So Trump can never be classified as poor, but Obama could be classified as poor. So data collection. So we have non-probabilistic, and probability. So non-probabilistic, asking people a specific audience. So in our case, if we're polling for a political party and we asked 40-year-old white males about their political standings, we're going to get a skew as if we asked the whole of the population. And then probability, selectively sampling data out. So, for example, that might be something like selecting people from the last film they watched. So, if I was creating a new film and I just wanted to hear people's opinions who had just watched the latest blockbuster, I'm going to get a different opinion than if I surveyed everyone. So, like I said, going to cinema, you're going to have bias by the fact that you're talking to cinema goers and by the fact that they've just watched a particular film. So we have publication biases as well. So this is a kind of good example of this is if you had if you had if you told people that painting a child's room blue would increase their mental capacity, um, there's a good chance that 15 years from now you'll be able to prove that actually children with blue rooms have good mental capacity, not because blue rooms give good mental capacity, but because the parents that heard that are more likely to be invested in their child's well-being and their child's learning if they're going to be invested in colouring the room blue. That won't be the only thing they do. They'll be investing in extra tuition, that kind of stuff. Then we have recall bias. So there was a classics survey of ladies that studying their diet and then seeing if they had developed breast cancer. The ladies that had not kept a journal, and then it was revisited, I think 10 years later, something like that. And the ones that had developed breast cancer felt that they had had a fattier diet than those that hadn't developed breast cancer. Um, but looking at the data, it was they had pretty much the same kind of diet. So there's recall bias. So if you ask if you're surveying, there is a good chance that people will recall things differently based on the scenario and the situation. So again, lots of things to take into consideration. Here's a good Gartner quote: through 2020, 85% of all AI projects will deliver enormous outcomes due to bias in data algorithms and the AI teams that choose the data in the algorithms. Okay, so bear that in mind. You're probably, if you're a data scientist and you're working on a project, a model, it's likely that you've got some bias in there that you haven't realized. Again, we'll talk about some toolings later. Things that typical things: face recognition, speech recognition, image recognition, typical aspects of AI. All of them can be unbalanced in terms of gender, in terms of age, in terms of ethical groupings. So when you're going around and you're creating a model, you need to think about the data you're collecting, where the data is coming from, and if you have included everyone in that data set. Here's an audit in 2019 of accuracy and gender classification and race. So as we can see, Amazon really good at identifying white males with its face recognition, but it's really bad identifying black females with its face recognition because they haven't been using a representative data sample. They've obviously been training their data predominantly on white males. It's quite a good service. We come quite high up. Now we're not perfect, but our, our gap is only 1.5% in terms of the data collection and model creation. So yeah, good to bear in mind. So how to deal with bias? Is bias ever acceptable? We're talking about bias quite negatively. It's not always a bad thing though. So if you're applying for a loan, you don't want bias. You don't want to be told I can't have a loan because I'm a black female. That's obviously a big problem. So not really acceptable in terms of giving people a loan, but in medical care is acceptable to have to sorry, it's in medical care there is a difference between men and women, and they have different problems. And one of the problems that we have with a lot of our medical systems is that they've been created based on how a male body works as opposed to how a female body works. So identifying a heart attack is women give different symptoms than a man will give, but all the tests are male orientated. So you can't just have one model. You can't just have one way of doing things. It needs to be biased towards women or biased towards men. You have to have different models. Here's a really good example as well. This is if you go to translate and you type in here's a nurse, she's a doctor, put it into Turkish and then convert it back from Turkish to English, it'll come as she's a nurse, here's a doctor. So it reverses the roles because the translation presumes that nurses are female and doctors are male. So kind of enforcing those stereotypes. So we look at other aspects of representational harm that have happened in the world. Google have got quite a few examples of this. So this example where Google was identifying the black couple as gorillas, obviously racial stereotyping, etc., etc. In terms of if you used to put in 3 black teenagers and 3 white teenagers, you'd get lots of pictures of white teenagers having fun, and you get lots of pictures of black teenagers that were mug shots, etc. We see this is a passport upload system. So it's this one. We can see that it's telling the subject that his eyes are closed. His eyes clearly aren't closed, but obviously this model was trained on Western eyes. Okay, so it's a good quote. Ignoring patterns of systemic oppression and privilege leads to unacceptable machine learning. It leads to unacceptable machine learning systems that are deeply opaque and unfair. So you need to understand where biases are, you need to understand where cultural biases are, etc. Here's a good example from us. This is a Bing search in 2018. If you put in CEO, you would get a list of a lot of pictures of white male CEOs. So reinforcing the fact that to be a CEO, you have to be white and male. So now, and now we've changed that over time. So then we come to later on in that year, September 2018. So we see some females here and people of different ethnic backgrounds. And then 2019, we get a much wider range of people. So we're not enforcing that stereotype that you have to be white and male to be a CEO, which obviously if people have that stereotype in mind, they're not going to want us to be bringing in a CEO that's not white and male. Yeah. So um, representational harm. In terms of ethics, we created a chatbot called Tay. Now, this was a really good machine learning experiment in terms of we created a chatbot that you could talk to and it would learn and it would talk back to you in the way that it had learned. It worked really well in terms from a purely um, technology perspective because it did learn. In terms of marketing, this went south very quickly. I think we turned it off after a day because a lot of people on 4chan started talking to Tay, and as any kind of thing that learns, if you talk to it in a bad way, it's going to start talking back in a way. So it learned, but it was a media disaster. Now, if I show these, say these are not the representative opinions of Microsoft. This is just what happened to Tay, and we took it offline. And I've had to edit some of these out as well. So yeah, so it became basically it became a racist, over sexualized bot. So as you can see, some of the things it said, it started saying because it had been taught the wrong thing. So this leads us to again think about ethics. If we create a bot that can talk, what do we need to do to that bot to make sure that that bot is not? If we make a bot that can talk and learn, what do we need to do to for it to only learn the correct thing, so it doesn't do any representational harm to people, and it doesn't cause offence to people? This is a great example of something we did where we didn't put those safeguards in place to stop it learning bad things. Because if it would just been a child and you introduce that child into a bad environment, that child is going to end up saying some pretty um, bad stuff. So, when you build an app or bot, how do you deal with bias? You have to understand the stakeholders. You have to understand if your person you're talking to could be harmed by what you're saying. Could the owner of the bot be harmed? So the company that's using the bot could it be misrepresenting them? Could the audience, if anyone sees that conversation, be harmed? Could, if you're talking about a particular person, if the bot's talking about someone, could that be harmful to them? So lots of different aspects you need to think of in terms of potential for harm. So we normally go with the adage, design for 3%, solve for 97%. So think about the minorities, think about the potential for harm, and then you more likely to cover all potential things. Okay, so let's just skip over some of these slides. So it's in terms of Microsoft, our approach in terms of AI, we should make sure we want everyone to have benefits of AI. We democratize AI. And we want to kind of give you a comprehensive stack for AI. So, but in terms of ethical problems, what do we do? So, it's a quote from Satya: the most crucial next step in our pursuit of AI is to agree on an ethical and empathic framework for its design. So what we do is we have multiple systems in place. So we have the partner pledge I'll talk about in a minute. We think about where things are in terms of ethical. So you have in this we have the kind of illegal acts, we have the legal minimum. Like I said, the legal systems have not caught up to the technology that has been happening to so you can't really go on the legal minimum. You have this whole grey area of if it's ethical or not, and then you have your ethical maximum. Like I say, defining what ethics is still a little bit problematic because we have different schools of ethics to consider, but yeah, so it needs a lot of thought. We have a partner pledge, so any of our partners, we make sure that we ask them to pledge that they'll do responsible and ethical AI. We also have internal systems to make sure that any AI we do has been thought through properly. So in terms of AI, we make sure we do responsible AI. We do AI for good. We have helped create this organization, the Partnership on AI to Benefit People in Society, which is linked to lots of organizations, BBC, Amazon, Google, etc., etc., to make sure that key organizations are abiding by ethical principles when they're consuming and using AI. We've recently been to Vatican to talk to the Pope with IBM on ethical use of AI. So it's becoming far reaching. So what kind of things do we also do to help in terms of AI? So we also have the ability to do interpretability of your models and fairness of your models when you're training models. So we have FairLearn and Interpret ML as packages that you can use with Azure Machine Learning. We have best practices in place. So if you look at the link on the bottom, you can go here, a guide on responsible innovation. And in this, we have kind of frameworks in place. So we have harms modeling. So it's a framework to understand the potential harm you might be doing in creating a model. So it's good to go through the processes of this framework to identify all the stakeholders and any person that you might be creating harm to when you're creating your model. We have the kind of concept of a commitment jury, where it's a technique to bring in people and make sure that there's no harm that's being done that overlooks it. And we've also got this quite fun game called Judgment Call that you can use it as like a card game where you can go through and you can and think about your projects and in a kind of fun way, and think about the kind of ethical implications and if there's anything you need to do to change that. So fairness in AI. I'll skip over some of these with time, but effectively we've got these modules in here that will let us break down when we train a model. It'll let you break down that model and see if it's fair across different features. In this example on the right, we're looking at male and female. So this is a loan application, and we can see that there is a disparity in the male and female. And more males are being given a loan as opposed to females. So we can see that this model, it might not be very fair. Excuse me. And then also as part of this, we have the ability to you can then train a model using these functions to then create a model that is fairer and will be a better distribution of will not take into consideration the gender or the race, etc. If you're giving a loan. So you can give it features and you say, these features I want to make sure it's absolutely fair with these features, so it's an even split. So I don't have time to demo that, but make you aware that's available. Other incentives that we do in terms of ethical and moral things. So we AI for Earth, over 50 million invested, AI for accessibility, AI for humanitarian action, cultural heritage, AI for health. And these are quite a good set. This is Satya's rules for AI. AI must be designed to assist humanity. AI must be transparent. AI must maximize efficiencies without destroying the dignity of people. AI must be designed for intelligence, privacy. AI must be algorithmically accountable, and AI must guard against bias. Okay, so those are the kind of key rules for thinking about any AI, which should also be kind of your rules for thinking about AI and thinking about when you're going around creating a model, the kind of features, etc., that you would be using, and how you've got that data, and how you're sampling that data, and is that representative data, and are you creating something that might harm someone? Okay, so that's the end of the talk. So I'm not sure we'll have feedback, but I hope you've enjoyed it, and we'll finish there. Thank you.